Welcome to my classroom. Today's lesson is over integers and graphing. So again, as a number routine is about today's number. With your tribe, tell me everything you know about positive and negative numbers. So what do you know about positive and negative numbers? Well, one thing you can say that you can find them on a number line. 0 is neither positive or negative. You'll see positive numbers to the right of 0, and you'll see negative numbers to the left of 0. This is a horizontal number line. You can have a vertical number line such as this, where 0 is in the center, and positive numbers are north of 0 or above 0, and negative numbers are below 0 or south of 0. Notice how when we count the negative, it's counting by -1, -2, -3. It's counting, you can almost say it's like, think of it as backward. So there are two types of number, positive and negative. Positive means you have something, like it's like a deposit, while a negative number is like you owe something. So many things to say. All right, so what we're going to do is we're going to do something called walk the line. On the floor, you will find a number line. Let me label it now. Let's see. Let's use blue. 0, 1, 2, 3, 4, -1, -2, -3, -4. Now we're going to answer some questions about this number line. First of all, we're going to fill in the blank integers. Done. Again, integers. What is the opposite of 4? So right here we see the number 4. What is the opposite of 4? I think it's -4. But how do you know that -4 is the opposite of 4? Some people will say positive, the opposite of positive is negative, opposite of negative is positive. That's one way. Well, let's think. 4 is 4 units from 0, and -4 is also 4 units from 0. This is 4 spaces from 0. What number on the negative side is also 4 spaces or 4 units from 0? -4. What is the opposite of -5? So we have a -5 right here. What number will be on the opposite side? It would be 5, but show me. So we would actually have two students standing on the number line. So the -5, they would count. There are 5 units to 0. And while the number 5 is also there are 5 units from 0. What is the opposite of 0? What is the opposite of 0? I believe it's 0. So is 0 positive or negative? It's neither. Because 0 is 0 spaces from 0, so it's neither. Next one. Integers are whole numbers and their opposite. That is what we are learning today. Integers are whole numbers and their opposite. For example, on this number line, I see integers. I see whole numbers such as 1, 2, 3, 4, 5, 6. The opposite is -1, -2, -3, -4, -5, -6. Locate 1.5 on this number line. So if I had to locate 1.5 or 1.5 on this number line right here, is that an integer? No, it is not. Why or why not? Because an integer is a whole number such as 1, 2, 3, 4. It's something and its opposite, which is -1, -2, -3, -4. Here's a trick question, thought-provoking. What is the opposite of x? X is a variable. A variable is a symbol, usually like a letter, unlike X, Y, or Z, or it could be any symbol that represents a number. So what's the opposite of x? Negative x. So if x was 8, the opposite would be negative x, or negative 8. If x was negative 10, the opposite would be 10, or x. So opposite of x is negative x. All right, now, on the board, you will see this display that says 6th grade boys with glasses, 6th grade boys, 6th grade students, and all students. So if you were given a sticky note, I would like you to write your first name and place the note in the most appropriate circle of the Venn diagram. Which label best describes you? So for example, I may have a student named John. John is in my class and he's wearing glasses. So even though he is considered a student or a 6th grade student or a 6th grade boy, what best describes him is a 6th grade boy with glasses. What if I have Jessica? She's a girl. Which one best describes her? A student. Is there a better description of her? What about a 6th grade student? Could she be a 6th grade boy or a 6th grade boy with glasses? No. So Jessica. So Jessica can be a student or a 6th grade student. But what best describes her? A 6th grade student. So like John. John is in my class. He's wearing glasses. He's a 6th grade boy with glasses. But can he be a 6th grade boy? Yes, he can. Can he be a 6th grade student? Yes, he can. Is he a student? Yes. But what is this best description of him? What about we have Paul? He's a 7th grader. For some reason, he just misses my class and he won't leave my room. So which category best describes him? Well, he's a 7th grader, so it can't be the inner circles. So Paul would probably be out here. He'll be a student. It could be a kindergarten student to a college student. But only 6th grade students can go in here. So now that we understand that a little more, why are there no notes in the all student circle? Who could be part of that group? Well, in our classroom is a class, it's a 6th graders. So there will be nobody. Paul came in later as a 7th grader. So only 7th and 8th graders at our middle school or junior high can be in the all student. But if you are looking at the students, the 35 plus students in my classroom, they'll either be a 6th grade student who's either a boy with glasses, or to be a 6th grade girl who still be considered a 6th grade student. But it would not be, even though they are students, but the best description of them would be a 6th grade student, a 6th grade boy, or 6th grade boy with glasses. You have to get the 7th and 8th graders to be up here. So how does this relate to our study of classifying numbers? There are 4 types of numbers we learn in this class. We learn something called counting and natural numbers, whole numbers, integers, and rational numbers. We just walked a number line about integers. Do you remember what integers are? Examples of them? So here's our first question. Give examples of counting natural number. Counting. Stick out your fingers. If you stick out your fingers, I would like you to count. What's the first number you can count with? 1, 2, 3, 4. So you know what? I'm going to write it down here. We have 1, 2, 3, 4, 5, and like maybe 12. We can count with up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count with back the next finger, 11, 12. So examples of counting or natural numbers are numbers you can count with your fingers. 1 through 12. You can count all the way to 100 if you want to. I wouldn't recommend it, but you could. So next one. What numbers belong in the whole number sections? Well, in the whole number sections, whole numbers are things you've learned since elementary school, like 0, 1, 2, 3, 4, 5, 6, 7, 8. So we could say, let me use a different color. use red. 0. What about 1, 2, 3, 4, 5? I could put a 1, 2, 3, 4, 5, 6, 7 in the whole number right here. But isn't 1, 2, 3, 4 better described as a number I can count with, a counting number or a natural number? Yes. So 0 is so the only whole number I will see in this classification is 0, because the numbers 1, 2, 3, 4, 5, 6, they are whole numbers, don't get me wrong. But do you see how you have an outer circle? Whole numbers and counting. Whole numbers can be counting and natural numbers. So we're done with that category. Next category. Give examples of integers. Integers can be, take out my, integers can be like -1, -2, -3, -4, -5, -7, -12, -15. What about 1, 2, 3, 4, 5, 6, 7? Remember, integers are whole numbers and are opposite. I could put 1, 2, 3, 4, 5, 7, 12, 15 in this circle, but wouldn't those numbers be better described as counting numbers? So integers can be whole numbers and counter numbers. So integers is everything inside this circle. So integers are whole numbers, and it's opposite, like -1, -2, -3, -4. So it could be 0 is an integer, counting numbers are integers, and these opposite of like -1, -2. So now that we have that, what are we left with? I don't know why it keeps unclicking. Rational numbers are numbers that can be written in fraction form as fractions. For example, 2/3, 1/2, 4/10. Can the number 3 be written as a fraction? Can it be a rational number? Can it be written as a fraction? Yes, it can. What's 3? What's the improper fraction of 3 divided by 1? That's 3. However, isn't this better, the number 3 better represented as an integer, a whole number, or a counting number? It's probably best represented as a counting number. But a rational number can be an integer. It can be a whole number. It can also be a counting or natural number. So that is best represented right there. Can decimal be rational numbers? Right here, you see a decimal of 4/10. Can it be written in fraction form? Yes, it can. So it can be. So yes, it can. And last but give examples of rational numbers, and we did there. Fine. So we're going to be studying rational numbers more in lessons about 2 or 3 weeks from now. So I'm going to pass out 12 numbers throughout the classroom, and then you are going to put them inside a baggie that you think best represent the best description of it. For example, the number 5. Where would 5 go? It's an integer. It's a whole number. But can I count it with my fingers? I think it's best described as a counting number. The fraction 1/2. It's in fraction form. I can't count it with my finger, unless I cut off part of it. So I believe is best represented as a rational number. The number 1, I can count it with my fingers. So 8, I can count that with my fingers. 2, I can count that with my fingers. Let's look at this one. 15, this is improper. How many 5s go into 15? 3. 3 is a counting number, so it goes here. Some people will put it in rational number, but it could be a counting number. Whole numbers. Can I count 0 with my fingers? No, not really. It's called a whole number. When you start counting, the first finger you count with is 1. So it's a whole number. Integers. Integers are whole numbers and they're opposite. So even though it could be 1, 2, 3, 4, 5, it's best represented as a counting number opposite, such as these. And then the rest, 1.5, 1 and 5/10, that could be written in fraction form. -3 and 2500, that could be written as a fraction form. 4 and 5/10, 2/3. And last but not least, this repeating decimal. So the first question is, why did you classify 1.5 as a rational number instead of an integer? A rational number is a number that can be written in fraction form. Integer or whole numbers are opposite. If a number fits into all four categories, where should it be placed? In rational number or counting numbers? Counting numbers. Let's think of the number 5. Is 5 a whole number? Yes. Can 5 be an integer? It's a whole number opposite. Can 5 be represented as a fraction? 5/1. Yes, it can. So here are a combination of our notes. You'll be getting this note page. Accounting or natural numbers are like 1, 2, 3, 4, 5, things you can count with your fingers. Whole numbers are counting numbers, but it also includes 0. Notice how there are no fractions or decimals. Integers are like whole numbers, but they also include negative numbers, the opposite, but still no fraction decimal. So integers can be negative, like -3, -2, -1. Positive, like 1, 2, 3, and it includes 0. Our upcoming quizzes and tests, kids do get it wrong about 0. They don't think 0 can be an integer. Integer is a whole number and it could be the opposite. Rational numbers are numbers that can be written as fractions, such as decimals. So I would like you to come up with 2 examples for each circle. So for example, think of a natural number or a counting number. 7 and 10. I have 7 fingers and 10 fingers. Think of a whole number. What about 5? But it's better represented as a natural number. So 5 should be placed right here instead. So are there any? Yet 0. 0. So let me get another 0. Because when you count with your fingers, the first number you count is 1, so it's a whole number. Integers. Integers can be like whole numbers, like 7, 5, 10, but it's already represented as a natural number. It could be 0, and it's opposite, like -7, -5, -10, -3, -6. And rational numbers are any numbers that we represented as a fraction in fraction form. For example, 3/4, 5/3, 1 1/2, 1 5/10, 75/100. What about 6? Can 6 be represented? Yes, it can be. 6 can be written as a fraction, 6/1, or a decimal, 6.0, but it's really represented, it's best described more as a natural or counting number. So if you look at this chart, are there any numbers in the wrong spot? Let's move them if they are wrong. Whole numbers. 0. 3.5, that's a rational number. -7, whole numbers have to be positive, so no. Let's see. 14 is a whole number. 6 is a whole number, because whole numbers are positive. These are negative. 3/4 is better, represents in decimal fraction form, so that's be a rational number. We're done. All right, so now I would like you to brainstorm everything you know about number lines. As you can see, number lines could be vertical and number lines could be horizontal. Which number line should you use? It really does not matter. Both number lines are great. If someone says they withdrew $5, what does that mean to you? Let me take all these out right now. If someone said they withdrew $5, what does that mean to you? We're going to mark it in either one. Let me get my, I'll use calligraphy pen. So withdraw $5. Withdraw means take away -5, so, or it could be this -5. I earn $5. Well, the opposite of withdraw is I earn money. So earn $5 would be positive $5. Positive $5. 3 feet below the sea. If sea level represents 0 feet, below mean negative 3. Negative 3. I would probably use for that one a vertical number line. It's easier to see. Deposit $4. I mean, I go to the bank and deposit. I mean, I'm going to have an extra $4 in my account. So deposit $4. So to generate a real world situation for a positive integer, for example, let me go put these out. Put this one out. Let me get my pen. So in the first example, it says deposit $5. How can I write as a number line? Do you want 0 to be the center of your number line? Did you know it does not have to be in the center? 0, for example, could be right here. These are negative. These are positive. To the right of 0. Deposit means I put money in. I'm going to have more money, so put a big dot for positive 5. And then withdraw means I take out. So if I want to, I'm going to make 0 right here this time. 1, 2. So positive integers to the right, negative integers to the left. So when I withdraw $2, I mean I take away, so it'll be right here. How would you show it on a griddable? On STAR test, we have something called a griddable like this. Well, do you bubble in the positive or negative? The negative sign. Negative 2, let's think, negative $2. How would you say that in decimal form? 2.00. So we know that the 2 goes right here. Negative 2. So we bubble in the 2. Negative 2. If you would like to add the 0 behind it, you may. You don't have to. In 5th grade, they may have told you that. In junior high, not so much. Negative 2. And that is our study. Oh, our last one is, the submarine is 24 kilometers below the sea level. Represent the situation as an integer. How would you represent 24 kilometers below the sea? Well, if sea level is 0, below means negative 24. So I bubble in the negative sign, the 2, and the 4. If you put the 2 and a 4 behind, in the digits behind the decimal point right here, then it'll be 0.24. We're looking for 24, negative 24 kilometers, so negative 24%. So this is a study of integers and graphing.